Okay, Honors Higher Algebra, what I wanted to focus on for our very last day was rational functions. It was the most unusual cumulative test that we just recently took, where kids would get a straight A on the part that was about polynomial functions and just bomb this part. So clearly we need a little bit more practice on this. And so I strongly recommend that you find this file about rational functions and follow along with me. We'll do some problems together. You can do some problems by yourself. There's an answer key. So let's just remind you of the basics. So to start with, for a domain with number 1a here, we'll start with all real numbers because you can feed a function pretty much anything. But then you got to figure out what are the exceptions. X cannot be what? Well, do you mind if the top is 0? No, it's okay if the top is 0. Do you get that the bottom can't be 0? Because if you divide by 0, it's undefined. So I'm going to have x on the top, and I'm going to have an x here factored out of the bottom, because if you can factor it, you should. And an x plus 7 left. Now, I think you remember that if something cancels like this, it makes a hole. And so the hole here would be at 0 comma something. Because if you put in 0, that makes a hole. It's both a 0 on the bottom and on the top. So if I let these cancel off here, it's going to be technically reducing to a 1 over a 1. That leaves a 1 on top and a 1 on the bottom, but 1 times the bottom will still be x plus 7. I'm going to just rewrite my nice, clean, simplified function. 1 over x plus 7, but it's not exactly the same as the original because the original had this hole in it here. So there's a hole at 0 comma what? You go put the 0 right here, and you have 1 over 7. 0 comma 1/7. All right. The vertical asymptote is whatever makes the bottom of the function 0, and that would be -7. So could I just write -7? I hope by now I've trained you that just a single answer like that's probably wrong. Asymptotes, the vertical one are the zertical asymptotes. X equals, so x equals -7. That is a vertical line at -7 that the function can't cross. Horizontal asymptotes are horizontal asymptotes. And for those, we figured out you can take the simpler part of the function and go way to the right and see if it had found a limit. Like, did it just kind of like start coming down to always getting really close to a certain number like this? So you go way to the right, which we used 1,000. So this would be like 1 over 1,000 plus 7, which is pretty much 1 over 1,000, which is pretty much y equals 0. All right, so there's a quick reminder of those kind of basics. But frankly, that may have been some of the problems that people had, but there was a lot more problems in, for instance, forgetting to factor stuff. So like here, do you remember how to factor this? It's called factor by grouping. I'd like you to take a minute, factor the top. I'll pause for a second while you give this one a try. Letter I. Okay, so I think you should have factored this first part and realized that there was an x squared in both of them. And then what do I have left? X minus 3. On this part, there's a 2 in both of them. I'm going to put a plus 2, because otherwise, mathematically, you need that plus. And then x minus 3 here. And the fact that these are the same is no coincidence. So, of course, those factor out. And I like to put them in the front, because everything else we factor out, we put in front. And then what's left is x squared plus 2. Now, that's all over the denominator here of x minus 3. So once again, we've got a hole, this time at 3. So now I've got a hole at 3 comma what? Well, my equation is now y equals x squared plus 2. If you know that 3 causes the hole, then you're going to go 3 comma and put the 3 back in, not here because it'll just make the function die. Put the 3 there, and you'll have 9 plus 2 is 11. 3 comma 11. Next, horizontals. Those are ones where we go way to the right by putting in like 1,000. And we'd get y equals, remember these are gone, 1,000 squared plus 2. The plus 2 becomes irrelevant. It's 1,000 squared. I put in 1,000, and I got 1,000 squared. That doesn't feel like it's limiting out. That feels like there's no asymptote. So if you put in a big number and you get a big number, then it's not leveling off when you go way to the right. Okay, the vertical here, vertical are the things that make the bottom 0, but there's nothing left. You might think that was it, but that was a hole. Can't be a hole and an asymptote. So, all right, so the vertical asymptote, there weren't any on this one. The only thing on that makes the bottom 0 is actually a hole. And your domain is all real numbers except x cannot be 3. Remember, holes and asymptotes both are excluded from the domain. Like if it makes a hole or if it makes an asymptote, then it needs to be listed here as a x cannot be. All right. Now there was a lot of people who made mistakes on the graphs. So my best advice there is just go through and find all these same things, except I guess you don't really need the domain, but if you can find the verticals, the horizontals, and the holes for each of your functions, it's just so nice to be able to start with that. And of course, if you can factor it, you should. You might have thought this one's going to have a vertical at -4. Nope. Because the 2 factors out. Then you have an x plus 4 on the top. That matches up with the x plus 4 on the bottom. And all of a sudden, there's a hole. And what's left here is y equals 2. What does y equals 2 look like? It looks like that. Except it is a hole at -4. Well, where on the line is that? I'm going to go erase a spot where it is. It's right there. Put in the hole. And then re-extend that back out. There we go. So I really pay close attention to this area. And again, you've got an answer key too. So this page, I think you're going to find that there's a lot of kids that struggle in this. And I think the best thing you can do is do practice problems that are like that. One last thought. Let's say you do have your asymptote in here, and I'm not saying this is in the right spot. Let's say there's an asymptote here, and maybe you figured out that there's a hole like right here. How do you do the rest of the graph? An XY chart. They're your best friend in graphing. So if I needed some points for this, I really ought to see if that top factors. Okay, but I don't even have to do that to find a point. So if I wanted to put in the number 1 and see what I get, it makes it look like -1, so I'm just going to erase that. So I'm going to put in 1 and see what I get. I have a 1 here and a 1 here and a 1 here. Then that would be 2 minus 1, which would be 1. 1 minus 3 would be -2 over 2. And -2 over 2 divides out to be -1. So I put in a 1, I got -1. So at 1, -1, and I just totally guessed at where the asymptotes were here, so I was making stuff up. These points will, of course, be on your graph. So at 1, -1, I've got a point. Let's just see if there is something that this will factor to. I betcha factor out a 2x and an x, and then I've got there's a minus in the problem, and so there must be at least one minus. If the last number is negative, you have a positive and a negative. And then to get a 3, I need to have a 3 times a 1, and I'm pretty sure I just did that, right? -3, +2 makes -1x. Yay, I just factored it right. And now I'm going to divide by x plus 1, and there is a hole after all. If I draw in the x plus 1 here, you can see that that creates a hole at -1. So if I put in a -1, don't expect it to work, because look, it makes a hole. And I could put hole at -1, comma, putting in the -1 right here, that'd be -2 minus 3 is -5. -1, -5 is way down here. There's a hole down there. And now, for asymptotes, I could use the 1000 trick to figure out what the asymptote for horizontal is. This is my resulting function after that cancels. So let's clean that up here, and y equals that. Well, interesting. This is just a straight line. This is not one of those functions that like goes like this. It's just a straight line that has a slope of 2 and has a y-intercept of -3. A lot of people got one like this wrong on the test. Let's see if you can do it right on the final. So here I'm touching -3 and has a slope of 2. Well, look at that. It goes right through all these points. It'll go through up like that, and up like that, and up like that to the next spot, and up like that, and just keep going like that, and it'll keep going like that, and there you go. I think this may be the thing that got people the most, is when it wasn't even a rational function. It just had a slope and a y-intercept. All right, so let's look at another kind of question. I don't think these were particularly vexing for anybody, so let's go to this page. Ah, yes, we give you the equation and you have to, or the graph, and you have to write the equation. And look, they all have holes in them, of course. So my best tip on this kind of question for number 3 is try to figure out the equation. Ignore the hole. Act like there is no hole. Write the equation for this thing without the hole. I swear, some of you started with the hole and then you couldn't figure out what to put. You did it backwards. You start by what's the equation for this. So take a second right now and try to figure out the equation for this line with that y-intercept and that slope. And then when you're done writing the equation, then go back and figure out what to put in to make that hole. So I see a -3 as my y-intercept, some kind of a slope. It looks to me like it's steeper than just -1, so it's probably -2, but I really need to look. And I'm going to go, oh, look at that. The slope is you go down 2 and over 1. It's a slope of -2x minus 3. Do you get how I got that equation? I figured out the y-intercept. I figured out the slope from looking at it going through lattice points like that and that. Okay. Now that I've got that, just put it in parentheses like this. Make it into a fraction. The whole unit is called rational functions, so they're fraction functions. And then you can add in the whole. And the whole will always be 2 sets of parentheses like this that are exactly the same. And you can look at the whole and try to figure out where it is. Oh, it's right above the -2. So x must be -2. So is it x, oops, change to a normal pen here. Is it x plus 2 or x minus 2? Well, if I do x minus 2 and x minus 2, I can say to myself, well, then +2 is where the hole is going to be. Oh, it's actually at -2, isn't it? So then it must be a plus and a plus. Now, do you see how I built that? Again, tons of people got that wrong on the last cumulative. I didn't even do the hole until the very end. And I did this equation by figuring out its slope and its y-intercept. Then I put parentheses around it and slapped in the hole. This one, the base is a 1 over x. I hope you know that. That's the 1 over x function. But this one's been moved. It looks like it's been moved 2 to the right, so you go minus 2. And then the whole thing's been moved up 1. I hope you remember that that means a plus 1 on the outside. Wish I had started with further to the left there. In fact, I need to, so I'm going to copy this over. Y equals 1 over x minus 2. That means it's moved 2 to the right. Yep. And up 1, so plus 1. But it needs to have a hole in it. Now, at the end, don't think about the hole till the very end. Where do you put the hole? I think the easiest place is right here. You've already got a fraction going there, right? And the hole's at 4. So then you'd have x minus 4, x minus 4. That will cancel out to make your hole. But don't cancel it, because the whole point was to write me an equation that had a hole in it. You don't want to cancel it out so it's not actually there. I'm moving my y equals over. And then putting my x minus 4 right here. There we go. I double checked just to be sure. I have a hole at 4 right there. Yep, got that right there. What's left besides the hole is a 1 over x minus 2, because that's been moved 2 to the right. And then it's all been moved up 1. That's this. Okay. This is a parabola, y equals x squared. But it's got a hole. So remember, don't do the hole until the end. All right. On to this page. It's even more of the same thing. So what's the advice? Ignore the hole and go, oh, that's 1 over x, except it's been shifted to the right 2. And then go put the hole in. I think you should be getting these right, like, super easily. All right. This is page 7 of 8. So we're getting close to done, boys and girls. The whole semester. Write an equation in factored form. And boy, a lot of people got this kind wrong too. So let's do A here. My advice is, if they want an equation, that doesn't mean that you can't make a sketch of what the graph would look like. I think some people tried to just write the equation and you know, kind of like gut it out and try to make sure each thing worked. Well, what I'd like to do is start with a sketch of what it looks like. It's got a horizontal asymptote at 0, so that's this kind. Horizontal is like the going across kind, like the horizon. There's an asymptote across there. And a vertical asymptote at 4. And a hole at -1. X equals -1. Well, let's do the hole last, like we said. So, what does that remind you of? I got my little sketch in here. You got those two asymptotes like that. Isn't it probably a 1 over x graph? Yeah, except it's been shifted. Which way has it been shifted? To the right 4. Would that match up with having a vertical asymptote at 4? Yeah, because it's what makes the bottom 0. All right, how about the horizontal asymptote of 0? Horizontal is the kind where you go way to the right by putting in x as 1,000. And this would be 1 over 1,000, which is pretty much y equals 0. It's working. Now, what if it wasn't working? Well, then I could try putting an x on the top or an x on the bottom, because just because it doesn't say that there's an x on the top or the bottom doesn't mean that there couldn't be. So if it isn't giving you the right kind of vertical or horizontal asymptotes, try putting in an extra x on the top. I don't need it in this case, but if I did, I could put an x on the top and see if, oh, does that give me the asymptote that I want? All right. Then last, but there's a hole. Let's say I've got it, and I'm going to put in the hole last. Like I told you, make it last. X equals -1 will be an x plus 1 on the top and an x plus 1 on the bottom. And it's a small thing, but I need a parenthesis around there. Now, those two green x plus 1s can actually cancel out and create that hole. Does this one, here's the kind of the key you should do at the end. I should check off each thing. Like, does mine that I just made have a hole at -1? Yeah, that's the green part. Check. Does it have a vertical asymptote at x equals 4? Yup. That's for this part. That would be a vertical asymptote. Does it have a horizontal asymptote? Like when you stick in 1,000? So if I stick in 1,000, the green parts will just cancel, and it'll be 1 over 1,000, which is pretty much 0, and so that works too. Yay. And if it didn't work, well, I'd have to just add some x's or numbers so that I can make it so that these things were true. Put stuff on the top or the bottom that you weren't sure was there. Just throw in an extra x and see if that changes it. All right. Those are key. You definitely should practice those, and we have plenty that you can practice. I was kind of dismayed how many people had forgot how to do the simple ones. Take a look at D. Would you take just a second and get a common denominator for these two? I hope it's insultingly easy. You multiply by the other denominator, so in this case x. You do it on the top and the bottom. And over here, you multiply by the other denominator, x minus 3, and an x minus 3. And holy cow, it was like half the class. They would realize that the negative went on the first thing that was here, but let's imagine that we had just had like an x plus 4 right here, which would probably happen again on the cumulative. Let's say there was an x plus 4 there. Do you get that this negative here would distribute and it would have to hit both parts? Because the negative would go on the x, and then the negative x would have to go to this and that. So tons of kids forgot to distribute the negative to the second number right here. Okay, if there's a negative here, it has to get distributed to that second number. All right, so, and of course, if you're dividing two fractions, you change this to a multiply, and then you flip it over. The 5x goes on the top, and the 12x plus 12, I'm smart enough to know that's going to factor. And now this that was on the top is now on the bottom, and the thing that was on the bottom is now on the top. And now I can multiply them. Then you factor this part. All of these are already factored. And then, a ton of kids made mistakes on reducing this. Like, do you get that that can be reduced? Everybody take a second now that I've given you some help. We flipped it over basically and factored part of it. Factor this the rest of the way and then give it your best shot. And I think this is the last problem we're probably going to do together. Maybe one more. We'll see. All right. Hopefully you're back from the pause. There's a 3 in everything there. It's a GCF of 3. And that'll leave behind an x squared minus a 9x minus a 10. And then there's a 10x on the bottom. Times, this was changed to times. So times 5x on the top and 12 parentheses x plus 1 here. Well, I know this probably factors again, so I may as well get to it. And look, there's an x plus 1 here. It's pretty likely there's an x plus 1 in it. Well, I guess we'll find out. There's minuses in it, so then this has to be a minus. Since the last number is negative, it must be a minus and a plus. It's probably a 1 and a 10. And look at that. 1 times 10 makes 10. And I'm checking the first outside, inside, last, and it makes negative 9x. Yep, it worked. I'm going to bring this 3 up here. Now I can just eliminate that. There, it's all factored. And look at all the stuff cancel. So the x plus 1s will cancel. The 5 and the 10 will cancel. And people sometimes don't know how that works. Let me show you. The 10 is really 5 times 2. So now you know that that 5 can cancel that 5. And this x can cancel this x. So it looks to me like there's just a 12 on the bottom and a 2 on the bottom, which makes 24 on the bottom, because this is a multiply problem. And on the top, it looks like I have 3 parentheses x minus 10. Oh, some kids left it like this too. They forgot that numbers have to be reduced too, not just variables. So then I like to think of this 24 as 3 times 8. That way, you can see that this 3 would cancel this 3. And I'm left with x minus 10 over 8. Okay, so this was probably the worst chapter of all of them, at least when it came to the cumulative. Happy to say there's nothing more to explain here. It's just the same kind of stuff. But please, for the love of all that is holy, just practice this one, because they're on the tests and they are not easy again. And it'd be great if you could get them right, finish the semester off right. So the next thing that'll happen is you'll have the final when you come back in a couple days. And that's all I got for you guys. I'll be rooting for you.